In food processing production, your whole goal is to reduce variability. You want to protect your brand, you want to protect your product quality, the safety of the food that you're producing. What makes DSI or direct steam injection more versatile? The fact of the matter that you can dial in a particular temperature and get that temperature in a very rapid format is critical to reducing that process variability.
Hello and welcome to the Pumps and Systems podcast. I am your host, Tom Baer, a managing editor at Pumps and Systems magazine. Today we're speaking with Scot Hull, regional sales manager at Hydrothermal. He's going to be telling us all about direct steam injection in food processing applications. So without any further ado, let's get into the episode. Welcome to the Pumps and Systems podcast, and thank you for taking the time to talk with us today.
Yeah, no problem. My pleasure.
So today we're going to be talking about direct steam injection. Before we get into the discussion, would you mind introducing yourself?
My name is Scot Hull. I live in Salem, Oregon, and I'm a regional sales manager for Hydrothermal. I actually came from the pulp and paper industry, selling specialty chemicals for about 25 years. And then I worked for Ecolab as a corporate sales manager in the dairy and cheese industry, focusing on sanitation, especially chemicals.
How long have you been in your current position?
With Hydrothermal, I've been, I think, seven months now, finding it to be a very interesting change and really enjoy it so far.
That's great. Okay. All right. So moving into our discussion about direct steam injection, or DSI. So can you give us just the basics first? So what is it and how is it different from like traditional heat exchangers in food processing?
Sure. Direct steam injection is very simple. It's basically heating with direct steam into a fluid of some kind. And this ensures very precise temperature control through mixing. And it differs from traditional heat exchangers by allowing direct steam and the fluid to mix directly, providing a very rapid and uniform heating. That's the real difference.
So what are some common applications of DSI in food processing?
In the past, I think most steam injection, when I've seen them out in the field, have focused on heating some kind of water source, either for sanitary hose stations or CIP or COP processes. That means clean in place, sanitation clean in place systems. But more recently, I would say within the last 5 years, we're seeing more and more uses in food and beverage production. So some common applications that I've seen recently are, other than sanitation purposes, starch conversion, starch cooking, milk pasteurization. In the dairy process, they take the whey and process it through micro and ultrafiltration and sometimes even RO. And we're using DSI to heat that whey product effectively, so they get more production through their processing of that through filtration. Tomato paste processing, baby food cooking, blanching of all kinds, vegetable blanching typically. Applesauce, pet food processing is big for us. Soup bases. I also personally have in my area a lot of plant food milk processing, soy milk, oat milk, those kinds of things.
So it sounds like it's being used in a very wide range of applications.
Yeah. Yep, absolutely.
Let's talk a little about steam flow. So can you explain kind of the different methods of controlling the steam flow and how that can impact the food quality?
With DSI, there's typically two basic ways. There's external modulation and internal modulation. So let's start with external. External modulation is where you have a steam control valve on the supply line of your steam, and you're actually changing that steam valve to control temperature. Unfortunately, that affects both the steam density and the velocity of that steam, and this can have some negative impacts. With internal modulation, it focuses on controlling the steam at the injection area itself. And therefore, you have higher steam pressure, higher steam velocities, which improve mixing and is conducive to complete and rapid condensation of the steam into the process fluid. So it's very uniform heating. Those are the only two methods for modulating steam.
What is it that makes DSI versatile in food processing?
That's a great question. And I think I'm going to answer it this way. In food processing production, your whole goal is to reduce variability. What I mean by that is you want to protect your brand, you want to protect your product quality, the safety of the food that you're producing, those kinds of things. So getting back to your question, what makes DSI or direct steam injection more versatile? The fact of the matter that you can dial in a particular temperature and get that temperature in a very rapid format is critical to reducing that process variability. I would say that's probably the biggest advantage of DSI is just the fact that you can get to your target temperature quicker, more energy efficiently, and maintain that and know that your process is stable for, longer period of time. So the downside to some heat exchanger type processing is the fact that it's indirect. And so your product can vary in temperature. And when you vary temperature, you're varying a number of other things, potentially texture, potentially flavor, and other things that can go on.
So then it's very good at consistency, we could say.
Yes. Yeah, absolutely. We target plus or minus 1 degree Fahrenheit. Reality is probably plus or minus 2 degrees Fahrenheit. But yeah, with very, very tight controls on temperature and thus consistency through the process. We can also vary the process gap, if you will, which impacts the pressure differential. And the nice thing about that is you can actually dial in for your different products how much pressure drop you want. And that can impact flavor. It can impact texture because there's more shear or less shear on the product and some of those other things. So there's some real advantages.
Yeah, and especially in the food industry, that kind of thing is really important since you want that consistent product and it could be dangerous if it's not consistent. So,
Absolutely. Especially in pasteurization or anything that has a potential bacterial issue, as
right.
we have seen in the news in the last couple of years with a number of products. Yes.
All right, so then continuing to talk about the food processing industry. So things like burn-on and fouling are pretty common concerns.
Sure.
So for our listeners and viewers who aren't familiar with those terms, what are they and how does DSI kind of address them?
Great question. I've seen it firsthand with tube and shell and plate and frame heat exchangers. When you have burn on, it affects the energy transfer, if you will, of heat because you have a coating on your plate and frame heat exchanger tube and shell. Buildup of scale and food burn on will definitely impact how efficient those heat exchangers are. We actually, in our sanitary heaters, we have an air gap between where the steam is injected and the process fluid, which helps reduce burn on considerably. Therefore, from a maintenance standpoint and a production standpoint, um, there's some significant advantages of using DSI because you don't have the maintenance issues, the production downtime that you would with typical heat exchangers.
Next, let's talk a little about shelf life. So, how does DSI help extend the shelf life of food products? And is the kind of precise temperature control a part of that?
Absolutely, especially for those extended shelf life type products like milk products or some kind of dairy products. You have to hit a certain temperature and maintain that temperature to get that extended shelf life in your product. So if you had, again, it gets back to variability. If you had a process that was more variable and you were hitting that temperature at some point in time and not hitting it, or the process itself is not consistent, you can not only potentially impact your extended shelf life products negatively, but you're also in jeopardy of hurting your brand because of that. In other words, name brand and brand recognition is everything in the industry. And so the consistency of DSI and the temperature control that you can get with DSI with less maintenance issues is very critical to those processes.
That makes sense. Yeah, and as you were talking about things in the news, when there's an issue with the food product, that brand definitely suffers because people don't want to continue buying when they might be risking
Correct.
food poisoning or something.
Correct.
So then how can DSI heating equipment be tailored to different cooking and processing needs?
Great question again. There's probably several answers I could give you. I just know from a personal standpoint, we take each application and we look at each application separately. So we gather all the information. We work with our application engineers to design a system that will meet whatever needs there are. Those needs can vary dramatically from one product to another. Sometimes they run multiple products through a processing line, having the ability to change pressure differentials for each product or run higher viscosity products versus low viscosity products and how you deal with that can all be designed and engineered ahead of time.
So then let's talk about the concern of DSI technology adding water to recipes. So what exactly are those concerns and how do we address them?
There are products, and DSI is not for every application. And because steam condensates in the process fluid, there is moisture added. In some applications, that moisture can be taken out through flash tanks where excess water is removed as condensate, and that condensate then evaporates, generating flash steam. Water addition formulas help adjust the water content of the product they're producing. And by incorporating sterile steam into the process for those products that don't mind excess water, you can improve product quality, texture, and flavor by adjusting, the amount of steam to that product as well.
So you might need to fiddle with it a little bit, but it's
Yeah,
surmountable.
yeah. And when we mentioned applications, there are a number of applications that's not an issue at all. And we're exploring many others as well. So again, I think for DSI, the technology is still, in my opinion, in its infancy stage. I think there's a lot of other applications we could explore that we haven't really yet, or maybe only have one or two applications, but it's really not well known in the industry what we're doing.
Well, do you want to tell us anything about the possible future of DSI, or is it still very much a secret?
No, it's not a secret at all. It's just exploring with those products. And, I'll give you a current example. In Alaska right now, the fisheries industry is changing rapidly. So mariculture is becoming more and more of a something that they're looking at because the fishery industry in Alaska has really gone down hill. And so we recently set up a system on Kodiak Island to process seaweed and also cook sea cucumbers for the Asian market mostly, but also here in the States. Some other opportunities are crab cooking and other mariculture products that we haven't really played a lot with, but that's just one application. There's probably several others. Some of our experience in the pet food industry may actually be very good for us, even processing, things like hamburger for packaged commercial goods. There's just a number of things that we haven't even looked into yet.
But it sounds like the possibilities are quite large at this point.
Yeah, and I don't think we've explored, nearly enough of what DSI can actually do.
So, is DSI used anywhere else in the industry aside from the direct application for food processing?
Well, sanitation,
Mm.
anything for sanitation, everything from hot water hoses for carcass washing and meat plants to clean in place systems after production of any food processing production schedule, sanitary host stations, those kinds of things. I would say right now that's a major part of what DSI equipment is sold into is for sanitation purposes. Again, having that consistency and temperature control is critical to getting them back up and running in a quick turnaround time frame. I've seen some of these heat exchangers, you're waiting 20 minutes to an hour for your CIP system to get up to temperature, and direct steam can cut that, dramatically. So every minute that you're not up and running, you're losing money. So, it adds up pretty quickly when you can do things rapidly and consistently.
All right. So before we wrap things up, is there anything else you'd like to say or any closing comments you have about our topic for today of direct steam injection?
I think there's, again, a lot of applications direct steam could be very good for that we just haven't explored. And therefore, I would say to your audience, if you have any questions or want to know more, we'd love to have you visit our plant or talk to us in person, and let's explore it together.
Okay, well, anything else? Last chance?
I can't think of anything else at this point in time. I will say that direct steam, even though it's a very simple process, I wouldn't say maintenance free, but definitely less maintenance than some other technologies in the food processing arena. And as we had talked about, uptime and production, that all makes good sense. Especially the fact that direct steam is almost 100% efficient, whereas heat exchangers are about 82% efficient when they're brand new.
Mhm.
And then as they're used over time, efficiency goes down even further.
Okay, well, then the only thing I have to do is to say thank you so much again for
Yeah,
taking the time to talk with us and appearing on the podcast. And I'm sure our listeners and viewers will really enjoy hearing what you have to say.
I appreciate it, Tom. Thanks.
Huge thanks to Scott for taking the time to speak with us today about direct steam injection. If you've enjoyed listening to the podcast and would like to watch it, hop on over to our YouTube page for the full video version. That's going to do it for today. Thank you so much for listening or watching, and we will see you next time.